All right, one last video just to give you some more practice on solving some rational equations. These are going to be a little bit more challenging in terms of the common denominators that you're going to be multiplying by, okay? So you will notice in this equation, the fraction that's on the right-hand side, 3 over x squared plus 9x plus 20, that denominator is not in factored form. Okay, I need it to be in factored form to identify my common denominator. Okay, so I'll begin by saying that this factors to x plus 5, x plus 4. Okay, so there I can now compare it with my other fraction to see that the common denominator is x plus 5 times x plus 4. So that's what I'm going to multiply both sides of this equation by. Okay. All right, so make sure on the left side that this is multiplying both the 1 and the 3 over x plus 4. So that's initially going to look like x plus 5 times x plus 4 over 1 times 1 plus x plus 5 times x plus 4 over 1 times 3 over x plus 4 equals, one last time, x plus 5 over x plus 4 over 1 times 3 over x plus 5, x plus 4. Okay, so now we reduce what we can. Those will become 1s. Those will become 1s. And those will become 1s. Okay, so what we're left with here is x plus 5 times x plus 4, right? Because that times 1 is still x plus 5, x plus 4. And then we have plus 3. You know what? I'm going to change my colors here just to stay consistent with how I've done this in the past. Okay, so that's blue. All right, now we've got plus the 3 times x plus 5 that are both left over equals 3. All right, now some of you might be able to jump right to that line without doing all the work that I have in the middle here. But if you need to, write everything out like I've done in that middle line where I'm using both the red and the blue colors. Okay, so now we just simplify the left side. If I multiply x plus 5 times x plus 4 back out, I know that's going to give me x squared plus 9x plus 20. Then I'll distribute the 3 to 3x plus 15. Okay, clean up the left side. Subtract the 3 over. And let's factor. X plus 8, x plus 4. X equals negative 8 and negative 4. Are either of those extraneous? Look back at the original denominators. Negative 4 is going to be extraneous, right? Because if I try to plug it in, right here, let's say, I'll end up dividing by 0. So we're going to throw out the negative 4, and we're only going to keep the negative 8. Okay. All right, one final example. Here, kind of similar. Notice the rightmost equation, or rightmost fraction, it needs the denominator factored. I can pull an x out here. And that's my common denominator, so I'm going to multiply by that on both sides. Okay, let's write that out. Okay, and then reduce what you can. Those reduce to ones. Those reduce to ones. 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 All right, so what's left over? We have 7 and x minus 1 plus x times 4x equals 4. So that's 7x minus 7 plus 4x squared equals 4, or 4x squared plus 7x minus 11 equals 0. All right, so now we got to try to factor that. I'm going to try, let's do 2x, 2x. I don't think that's going to work. So let's try a 4x and a 4, or a 4x and an x, I should say. Yeah, so I think I need an 11 here. I need a 1 here. Let's see, this is going to have to be a positive 11. This is going to have to be a negative 1 in order to create the 7x middle term of the trinomial, right? So in the end, x is going to equal negative 11 fourths, or positive 1. All right, now are either of those extraneous? Well, I think the 1 is. If you were to plug 1 back in to this denominator or the final denominator, you would get division by 0. So throw that out. There we go. All right, your turn. Pause the video. Try practice 2. When you're done, come back, check your work.